Water is flowing into a cylindrical tank at 10 cubic feet per minute. If the radius of the tank is 2 feet, how fast is the level of the water changing when it is 3 feet high? Well, so here we have a cylindrical tank, and in a cylinder we know we have a radius and we have a height, and that's about all we have here. So for our rates, we know that the water is flowing into the tank at 10 cubic feet per minute, and so that's actually going to be a volume. So dV over dt is going to be 10 cubic feet per minute. We want to know how fast is the level of the water changing. So in that case, that's going to be dH over dt. And we want to know this when it's 3 feet high, so when h equals 3. Now you also notice that the radius of the tank is 2, and this is pretty important that the radius here is constant. So this is not changing, but the height here is variable because the height is changing. Okay? And we know radius is constant because in a cylinder, the radius is always the same. But the height, right, as the water level increases, the height of the water actually changes. So let's go ahead and get our equation now. So we need an equation with V and H. Well, one equation we do have is the volume of a cylinder, which is pi r squared h. Now it's okay that it has that extra r in there because we know r is constant. So r is always going to be 2, so we can just replace that constant there. And simplifying this, before we derive, we would get v equals 4 pi h. Now we can go ahead and derive. So we're going to take our derivative of v with respect to t. It's going to be our derivative with respect to t of 4 pi h. Now you'll notice here that 4 pi is just our constant. So dv over dt will just be 4 pi times dh dt. So we still have our chain rule there. So now we'll go ahead and substitute everything we know. dv over dt is 10. 4 pi is our constant, and what we're looking for is dh over dt. And notice here that the height doesn't actually even change our rates. So pretty much what that's telling me is as this is increasing, because that radius stays the same, that it's increasing at the same rate at whichever height we're at. And you can see that because there's no h in this equation. So now solving for dh over dt, we're just going to get 10 over 4 pi, which is 5 over 2 pi. And this is going to be feet per minute. So that is how fast the height is changing with respect to time.